This is a Van de Graaff generator. A belt moves negatively charged electrons from the base to the sphere at the top. This produces static electricity. When another metal sphere or another type of conductor goes near the sphere, the electricity is transferred, creating an ignited bolt. It's the 1930s. Machines are advancing, inventions are being created. It's like the second industrial revolution. A new form of transportation has just been created, called an airship. The most famous of these? The Hindenburg. It was filled with helium and hydrogen, with a metal frame, and a lightweight cotton exterior. It was known as the Titanic of the skies. The Hindenburg was a beast of a ship, one to be marveled at. It was around 800 feet long and over 7 million cubic feet in capacity. Today, it would have cost $25 to $50 million to make. In its short life, it took 17 trips in total. Well, 17 and 1/2.
17 and a half? What was the half?
Well, on May 6, 1939, a disaster occurred, appropriately named the Hindenburg disaster. It was a horrific event. 36 people were killed in total. In the years following, many people believed it was caused by the engines overheating and exploding, but thanks to modern science, a true cause was discovered. On the day of explosion, it was storming. Now, everybody knows that lightning is made of electricity. You know when you rub your hair on a balloon and then when you touch your friend you shock them? Well, that's essentially what happened. The static electricity in the air transferred to the cotton that made up the airship, and then it was ignited by the hydrogen that filled the Hindenburg, causing the explosion. This could have been prevented had the science of the day been more advanced, as it is today. I believe that a different lightweight material could have been used to build the Hindenburg instead of cotton that wouldn't have transferred as much static electricity, preventing the explosion. Using the Van de Graaff generator, I conducted an experiment to test different materials and their ability to insulate static electricity. To keep this controlled, I started out with testing the maximum distance between the two metal spheres possible for an electric bolt to be transferred. Now, for the actual experiment, I did essentially the same thing as before, except with a different material on the sphere each time. To keep this experiment controlled and to eliminate all variables, I followed the same procedure each time. First, I would turn on the Van de Graaff generator and wait 3 minutes. I would then tape a piece of cotton onto the smaller sphere. After 3 minutes, I would line up a meter stick and hold the smaller sphere on one side, and then I would slowly move the sphere towards the Van de Graaff generator, waiting for a spark. Once that happened, I would measure the distance between the spheres. I did this 3 times for each material and recorded the results. What I was looking for was the lowest distance and the smallest range of values, which, obviously with the graft, is having nothing. But you can't have a blimp with no covering, or else you will crash. So, the nylon wins. So, with this evidence, we know that nylon was the most effective insulator in the experiment, as the spheres had to be closest for the electricity to be able to transfer. But, more specifically, it did way better than cotton, which was used in the Hindenburg. Today, airships are made of materials such as polyester and Dacron, which are materials that were unavailable in the 1930s. However, as nylon was invented in 1935, it would have been a way better material to be used in the Hindenburg and could have possibly prevented the explosion.